Time travel has been a fascinating concept throughout human history. It's an idea that has captivated the minds of scientists, philosophers, and storytellers alike. But despite the many ways it has been depicted in fiction, the real question is, could time travel actually become a reality? While many people imagine time travel as something purely speculative, scientists have been exploring whether it is possible based on our current understanding of the laws of physics. In this exploration, we will dive into these theories and examine how time travel could work. From Einstein's theory of relativity to the concept of wormholes, there are a number of different theories that attempt to explain the possibility of traveling through time. What's more intriguing is that some of these theories might just be closer to reality than we think. While time travel may still seem like a distant dream, some of the science behind it could potentially be realized. Let's start by exploring the most well-known theory of time travel: Albert Einstein's theory of relativity. Albert Einstein's theory of relativity is one of the most fundamental pieces of scientific knowledge that gives us insight into the possibility of time travel. According to Einstein's special theory of relativity, time is not a constant. It can be altered based on the speed at which you are traveling or the gravity you experience. This phenomenon is called time dilation. Essentially, the faster you move, the slower time passes for you compared to someone who is stationary. In simpler terms, if you were traveling at close to the speed of light, time would pass much more slowly for you compared to someone standing still. This means that you could travel into the future by moving at incredibly high speeds. The closer you get to the speed of light, the more time would slow down for you, allowing you to experience a few hours or days of travel, while years or even centuries might pass for people who remain on Earth. The concept of time dilation has been proven through experiments involving particles moving close to the speed of light. But how can this be applied to human time travel? Let's explore this in more detail. One of the main challenges to using time dilation for human time travel is that the speeds required to experience significant time dilation are far beyond anything we can currently achieve. The fastest spacecraft we have today travel at only a tiny fraction of the speed of light. Even with the best technology available, it would take thousands of years for a spacecraft to reach just a fraction of the speed of light. To achieve the necessary speeds, we would need a spacecraft capable of pushing the boundaries of current propulsion systems. There are theoretical ideas, such as ion drives and nuclear propulsion, that could potentially allow us to reach higher speeds in the future. But the question remains, can we ever achieve the speeds required for time travel? While scientists are exploring various methods of propulsion, it is still unclear when or if we will ever reach the speeds needed for time dilation to be used practically for human time travel. However, time dilation is not the only theory that scientists are exploring when it comes to time travel. Another fascinating concept is that of wormholes, which could theoretically provide shortcuts through space and time. Wormholes are one of the most exciting theoretical concepts in the search for time travel. In simple terms, a wormhole is a tunnel through space-time that connects two distant points in the universe. The idea was first proposed by physicists Albert Einstein and Nathan Rosen in the 1930s, and it is sometimes referred to as an Einstein-Rosen bridge. In theory, a wormhole could allow you to travel between two distant points in space in a fraction of the time it would take using conventional travel methods. But more importantly for time travel, some scientists believe that a wormhole could also connect different points in time. This means that traveling through a wormhole might allow you to travel into the past or future, depending on where the wormhole leads. However, while the idea of a wormhole is based on the equations of general relativity, there are a number of challenges that come with this concept. For one, wormholes are purely theoretical at this point. No one has ever observed a wormhole in the wild, and scientists are still unsure if they exist. Even if wormholes do exist, they would likely be highly unstable and would collapse quickly, making it difficult, if not impossible, for anything to pass through them. But could we ever stabilize a wormhole for time travel? That's the next question we need to explore. The biggest challenge with wormholes is their stability. In order to keep a wormhole open and prevent it from collapsing under its own gravity, scientists believe that exotic matter with negative energy density would be required. This exotic matter would work to counteract the gravitational forces that would otherwise cause the wormhole to collapse. However, no one has ever observed exotic matter, and creating it in a laboratory is beyond our current capabilities. Without this exotic matter, even if we could theoretically create a wormhole, it would likely collapse before anything could pass through it. To make matters worse, we don't know how to manipulate space-time to create a wormhole in the first place. It's unclear whether wormholes are even possible to create. While the idea of using wormholes for time travel is fascinating, we are still far from being able to stabilize them or even create them. But let's not forget that time travel could potentially be achieved through other methods as well, such as closed time-like curves. Closed time-like curves are another concept that has been suggested as a possible way to travel through time. These curves are essentially paths through space-time that loop back on themselves, allowing an object to travel to its own past. The concept of closed time-like curves arises from the equations of general relativity, particularly in the case of rotating black holes, known as pure black holes. If a black hole is rotating, it could theoretically create a region of space-time where time itself loops, allowing for time travel to the past. While this is an exciting concept, it raises even more questions. Would it be possible for a human or a spacecraft to survive traveling through such a curve? Could the forces near a black hole destroy anything trying to pass through it? As with wormholes, there are significant challenges to overcome in using closed time-like curves for time travel. However, the idea remains one of the most intriguing possibilities in the search for time travel. Even though the concept of closed time-like curves and wormholes is fascinating, both are still highly speculative and have not been proven to exist in any practical way. In fact, many scientists believe that time travel is not possible at all, at least not with our current understanding of the laws of physics. While time dilation has been demonstrated on a small scale with particles and satellites, the idea of traveling great distances or back in time presents a number of paradoxes. One of the most famous paradoxes is the grandfather paradox, which suggests that if you went back in time and changed something significant like preventing your grandfather from meeting your grandmother, you could erase your own existence. This raises the question, if time travel is possible, could it create irreparable contradictions in the fabric of reality? Some physicists believe that this is one of the reasons why time travel may never be possible. Others propose that any changes made in the past might create alternate timelines where paradoxes would be avoided. The idea of alternate timelines or parallel universes is one possible solution to the paradoxes of time travel. According to the multiverse theory, every time an event occurs in the timeline, the universe splits into multiple branches, each one representing a different outcome of that event. This theory suggests that if you traveled back in time and changed something, you wouldn't alter your original timeline. Instead, you would create a new one where events unfold differently. This would allow time travel to occur without causing paradoxes, as the original timeline would remain intact. While the multiverse theory is an exciting possibility, it is still a speculative idea with little empirical evidence to support it. However, it remains an area of active research in the field of theoretical physics. While the idea of parallel universes opens many doors, it also adds complexity to the concept of time travel. If every action creates a new branch of reality, then theoretically, each journey through time would spawn countless alternate versions of events, people, and outcomes. This means a single time traveler could create an infinite number of alternate timelines simply by making different choices in the past. It's a mind-bending concept that leads scientists to wonder whether our universe is just one of many, floating within a larger multiverse. Some physicists believe that evidence of the multiverse might one day be found in the cosmic microwave background radiation or in quantum fluctuations. Others remain skeptical. Nevertheless, the multiverse theory adds an exciting layer to the time travel discussion. It invites us to imagine a universe where every possibility plays out in some reality, and where time travel doesn't change the past, but simply shifts the traveler into a different stream of existence. This interpretation could allow time travel without violating known laws of causality. Another fascinating perspective on time travel involves quantum mechanics. In the quantum world, particles can exist in multiple states at once, a phenomenon known as superposition. This idea suggests that at the smallest scales of existence, reality is not fixed until observed. Some theorists believe that quantum mechanics may hold the key to unlocking time travel. For example, quantum entanglement connects particles across vast distances instantly, regardless of space and time. Could this imply a deeper structure to reality, one where time is more flexible than we perceive? Although the leap from quantum behavior to human time travel is immense, it raises important questions about the nature of time itself. Perhaps time is not a linear path, but a complex, interconnected web where past, present, and future coexist in ways we don't yet understand. The more scientists study quantum physics, the more they realize that time might be far stranger than our everyday experience suggests. It remains one of the most mysterious and compelling aspects of the cosmos. Time itself may not be as straightforward as we think. Some scientists propose that what we perceive as the passage of time is simply the way our minds interpret changes in entropy. According to the second law of thermodynamics, entropy, or disorder, increases over time. This means that time might be a byproduct of this natural tendency toward chaos. If this is true, then time could be an emergent property of the universe rather than a fundamental one. This idea challenges the way we understand time and opens new possibilities for how it might be manipulated or even bypassed. If time is tied to entropy, and if entropy can be controlled or reversed in some way, could we slow down or reverse time itself? While this remains a highly theoretical concept, it adds yet another dimension to the time travel discussion. Instead of building a machine to move through time, perhaps we need to understand and manipulate the very nature of entropy itself. This approach could offer insights into time travel from a completely different angle. Despite all the theories and possibilities, one question still lingers. How would time travel feel to the traveler? If we ever developed the technology to move through time, what would the experience be like? Would it be instant, like flipping a switch? Or gradual, like watching the world move in fast forward or reverse? These are questions that scientists can only speculate about for now. However, we can imagine scenarios based on current ideas. For example, if a person were to travel close to the speed of light, they might not notice anything unusual on their journey. To them, time would feel normal. But when they return to Earth, they might discover that decades or even centuries had passed. It would be a disorienting experience, like stepping out of your home and finding the entire world changed. The emotional and psychological effects of time travel could be as profound as the physical ones. The traveler might be forced to live in a future where everything and everyone they knew is gone. It's a powerful image that adds emotional weight to the science. When we think about the distant future, it's possible that time travel may not be achieved through machines or wormholes, but through biological or mental evolution. Some theorists suggest that advanced civilizations could develop ways to perceive or interact with time differently. Perhaps time travel won't require physical movement at all, but will instead be achieved through shifts in consciousness or perception. This idea is supported by accounts of altered time perception in meditation, near-death experiences, or even psychedelic states. In such altered states, people report seeing time slow down, stop, or even move backward. If human consciousness can experience these shifts without external technology, could a future version of humanity learn to navigate time internally? While this might sound mystical, some neuroscientists and philosophers believe that time, as we experience it, is a construct of the mind. If so, mastering that construct could be the key to a new kind of time travel, one that doesn't break the laws of physics, but instead rewrites the way we experience reality itself. The idea of mental time travel also connects to memory. Our ability to remember the past and imagine the future is a kind of time travel in itself. When we recall memories or plan future events, our minds navigate through time, replaying events or simulating possibilities. Some scientists believe that this cognitive ability evolved as a survival mechanism. It allows us to learn from the past and prepare for the future. Interestingly, studies show that the same brain regions are used for both remembering and imagining. This suggests that our sense of time may be deeply rooted in the brain's structure. If we can better understand how memory and imagination work, we might unlock new ways of manipulating time, at least in our own minds. Perhaps one day technology will enhance these abilities, allowing us to vividly explore past experiences or preview future outcomes with unprecedented clarity. In this sense, the future of time travel might not involve spacesuits or starships, but brain interfaces and neurosimulation. Another important aspect to consider is the ethical implications of time travel. If humans ever gain the ability to move through time, how would it be used? Would it become a tool for exploration, or would it be exploited for personal gain? Imagine a world where people could alter past events, invest in future economies, or change historical outcomes. The potential consequences would be enormous. Time travel could become one of the most powerful and dangerous technologies ever developed. To manage such power responsibly, humanity would need strict rules, ethical frameworks, and international agreements. Just like with nuclear energy or artificial intelligence, the benefits of time travel would need to be weighed carefully against the risks. Some philosophers argue that time travel should be forbidden altogether to prevent misuse. Others believe it could be a force for good, helping humanity learn from its past and build a better future. Regardless of the approach, the ethical questions surrounding time travel are as complex and challenging as the science itself. Science fiction has long played a major role in shaping our ideas about time travel. Through novels, films, and television, we've imagined countless scenarios where people leap through time, change history, or glimpse the far future. Stories like H.H. Wells' The Time Machine, or movies like Interstellar and Back to the Future have inspired generations to dream beyond the limits of the present. While these works are fictional, they often contain kernels of scientific truth, wrapped in imaginative storytelling. They allow us to explore complex ideas in ways that feel human and relatable. In many cases, fiction anticipates real scientific advances or even inspires them. Scientists who study time today often cite sci-fi as one of the reasons they became curious about the universe in the first place. The boundary between imagination and reality is thinner than it seems. What we dream of today could become tomorrow's discovery. In this way, storytelling is not just entertainment, it's a laboratory of ideas where impossible futures are born and tested in the minds of millions. Another area of exploration is the concept of time as a loop rather than a straight line. Some theories suggest that time might be cyclical, repeating itself endlessly in a cosmic cycle. This idea is found in both ancient philosophies and modern physics. In such a model, time travel might not involve moving forward or backward in a line, but rather recognizing patterns and cycles that repeat. Imagine a universe where everything that has happened will happen again, and everything that will happen has already occurred in some form. This idea blurs the line between fate and free will. If time is a loop, then perhaps events are not truly random, but part of a larger cosmic rhythm. This interpretation challenges our linear view of history and introduces new ways to think about the future. Instead of breaking the timeline, a time traveler in this model might simply be riding its natural curve, arriving at points that were always meant to be revisited. It's a poetic and deeply philosophical view of existence. Let's imagine a future where humanity unlocks the ability to travel through time. What would society look like? Would history become a subject we study by visiting it? Would future generations become accessible neighbors instead of distant descendants? This kind of reality would reshape education, relationships, and even identity. People might carry not only the memories of their own lives, but also firsthand experiences of centuries past or future. Traditions and wisdom could be preserved in more vivid ways, allowing cultures to maintain continuity across time. On the other hand, it could also create confusion, with timelines overlapping and personal histories becoming tangled. Governments and institutions would face new challenges trying to manage a population spread across different eras. Yet, such a world could also bring humanity closer to understanding its place in the universe. Time, once seen as a one-way road, would become a vast terrain to explore, with endless destinations and stories waiting to be discovered. It's a breathtaking idea that stretches our imagination. Among the many theories about time, some believe it may not exist at all in the way we perceive it. Certain interpretations of physics suggest that time is an illusion created by our limited perception. According to this view, all moments in time exist simultaneously like pages in a book. We simply experience them one by one, giving the illusion of flow. If this is true, then the past and future are as real as the present. They just exist in different parts of the time. This idea radically changes our understanding of life and death, of beginnings and endings. It implies that every moment you've ever lived still exists, preserved forever in the fabric of the universe. The idea of time travel in such a universe is not about going anywhere, it's about shifting your point of awareness. This concept brings time closer to space, where movement doesn't destroy the path behind you. In such a reality, memory and destiny merge, and time travel becomes less about machines and more about perception. If one day we learn to move freely through time, it may not be because we built a machine, but because we evolved to understand and interact with time differently. Future humans or beings more advanced than us may not be bound by the same temporal limitations we face today. They might perceive time as a landscape, walk through it as easily as we walk through a room. To them, past, present, and future may all be accessible, like turning pages in a storybook. This raises questions not just about science, but about consciousness itself. Could time travel be the result of expanding awareness? Could our minds one day grow beyond linear thinking and enter a new mode of being? As technology advances and our understanding deepens, the boundary between what is physical and what is mental may dissolve. Time travel in this context becomes a symbol of human potential, a reflection of our desire to explore, to understand, and to reach beyond what we know today. Before we end our journey, let's reflect on the wonder of even asking the question, is time travel possible? The very fact that we can imagine it speaks to the incredible capacity of the human mind. Whether time travel remains forever theoretical or becomes a reality, it continues to drive curiosity, creativity, and scientific discovery. Every step we take in understanding time brings us closer to understanding ourselves. The universe is full of mysteries, and time remains one of the greatest. It shapes our memories, our goals, our sense of self. It's the backdrop of every story we live. Exploring time through science, philosophy, or imagination is not just about seeking answers. It's about embracing the unknown, daring to ask big questions, and reaching for possibilities that once seemed impossible. Thank you for joining this voyage across the fabric of time and space. As we bring this episode to a close, let the ideas echo gently in your thoughts. Now, as the stars continue their silent journey across the night sky, allow your mind to drift among them. Let the questions about time become dreams floating softly through the quiet of space. You've traveled far, not in distance, but in thought. And as you rest, remember that time itself may be watching, quietly weaving its invisible thread through everything you are and everything you will be. Perhaps somewhere in the distant cosmos, another version of you is listening to this very story in another time, another place. So close your eyes and breathe in the calm of the universe. Let go of today and gently step into the mystery of what comes next. From all of us here at Night Cosmos, thank you for exploring with us. We hope tonight's journey brought wonder, peace, and a sense of awe. Subscribe if you haven't already. And now, sleep well, dream deep, and good night.